So if I had, for example, a -5 and I added a 5 to it, I would end up with what? 0. So your positive and negatives, right, they're basically considered inverses of each other, right? Okay, so that's kind of how we think of our functions. Okay, just like we finished doing on our graphs, to find the inverse graph, what we do, we switched our x and y. There are two ways that we can write inverse functions algebraically. One way is to reverse our operations, and another way is to switch the x and y, and that's the way I'm going to show you. So here's what we're going to do. We're going to switch our x and y. So write down your equation. We have f of x equals x minus 1/2. And we're going to go through the process of switching our x and y to write the inverse. Well, where is our y? It's the f of x, right? So first thing I'm going to do is I'm going to rewrite that. Now we're going to make the switch, just like you did with your graph. Switch the x and the y. So it would now look like x equal y minus 1/2. So now we're going to solve for y. So I'm going to rewrite over here since I don't have room. If we want to solve that for y, what do we need to do? We need to add 1/2. So let's do that. So our halves are gone now. So we have, on the left, we have x plus 1/2 equals y. But this y is now the inverse. So we're going to write it using our new inverse notation. So it's going to look like this. So we're going to have inverse. Our inverse function is x plus, does not let me, for some reason, I can't get it. X plus 1/2, it's not letting me put it on here. There we go. Okay, and so you have found your inverse. There it is. Not too bad, right? So here was our initial equation, and there is our new one. Questions on that? Okay. Well, in this one, it was a simple sign change, but we'll do one here that's a little more difficult. We're just going to start off a little easier here. Okay, now here's our second question. How do I check my inverse? So write that down, and I'm going to show you how you check inverses. All right, so here's how we're going to check it. Remember I said that inverses undo each other. So we're going to kind of see this process when we do our check. So we're going to do a check. All right, our original function was f of x equals, was it x plus or minus? X minus. So that was our original. I am going to, in place of the x, I'm going to input a 1. So let's input a 1. So that means we would have f of 1, let me redo that. F of 1 equals 1 minus 1/2. What's 1 minus 1/2? Half. So we get f of 1 equals 1/2. Okay, now we're going to take the 1/2 and we're going to put it into the inverse. Okay, and our inverse again was x plus a half. So, yeah, x plus half. Okay, so now let's take the 1/2 and we're going to put that in to our inverse. So, replacing with the half, we would end up with a half plus a half, and a half plus a half equals 1. So did these inverses undo each other? Yes. Did we start and end with a 1? Yes. So that's how you check it. So you know that you have the correct inverse. Because our input, so the output that we got from the original function, we put into the inverse, and it undid it and gave us back that 1. Okay, so that's how the inverses work. Questions on that one? Okay, let's do another one. Take this off. We good?
When you're doing the input, when you're checking, can you input any number?
Yes, thank you for that question. She asked me if we can put in any number for the input. Yes, you can. And that will come in handy when you have fractions. Okay? Sometimes you can kind of look at it before you start to check it, and maybe this number would be better for a fraction. So, good question. Yes, just so long as if you start with that number, you have to end with it. Okay, we're going to do this one. We have f of x equals 5x minus 7. So first thing I'm going to do is I'm going to rewrite that because I need to know where my y is. So y equal to my 5x minus 7. Okay, now make your switch. Okay, we're going to do our switch. We're not going to use inverses. So we really now have x equals to 5y minus 7. Can you solve that for me? I'll give you a minute. See what you come up with.
I got a question. When you place it, do you put it together or you put it
No,
together?
because they're not like terms.
Okay.
Good question. No, because when you divide by the 5, you divide into both of them, not just one or the other. So it'd be 7 on it. Okay. So did you move? So what'd you do first? Move the 7. You moved it as a positive 7. Okay. So now we have x plus 7. You didn't combine them, did you? All right. Okay, so you have 5 times y. So how are we going to get rid of the 5? We divide that. Now, if I'm dividing by 5 on the right-hand side and I come over here to the left-hand side, I have to divide it into every single term that is there. So I have to divide it into the x and I have to divide it into the 7. Okay? And so then over here, those 5s go away. And so we have, for our answer, or for our inverse, we have x plus 7 over 5. So let's come over here and rewrite that. Use your notation. So our inverse is x plus 7 divided by 5. Now, if you wanted to, you could split it up, but I would not do that. That'll make it harder for you to check it. So that is the inverse. So this is a little more complicated than that first one. It's not just changing signs like the first one. We get into some that require more steps. So let's check this. I'm going to input a 2. I'm going to input into my original, I'm going to input a 2. Okay, right here. So I'm going to have 5 times what? 2 plus 7. Oh, it's no, that's why it's minus 7, guys. There's something wrong. Okay, 5 times 2 minus 7 is
3.
Now, what are we going to do with that 3? We're going to put it in the inverse. So we're going to put the 3 into the inverse. So our inverse of x plus 7 over 5 becomes 3 plus 7 over 5. What does 3 plus 7 over 5 equal?
2.
2, right? Because you get 10 over 5, and look what we ended up with. 2. So are we right? Did we end up with what we started? Yeah, we did. So it checks out for us. Our inverses undid each other as we processed that 2 through both of them. Okay? Questions? Okay, things to be careful about right here. Be careful on steps like x plus 7. Do not make that a 7x, right? They are not like terms. So you will have expressions that look like this. Okay? It's okay. And then if you have to divide more than one term on either side, you have to divide into both of them. So we're technically saying x is being divided by 5, and so is the 7. Okay? Remember, when you have something like this, remember they're attached with a plus. When things are attached with pluses and minuses, they're a unit now, and we can't split them up. Okay? Any other questions? How are we doing on time? How many? Okay. All right. We'll go ahead and stop there.